As society advances, more and more products are available for consumers. At the same time, a greater number of diversified models and options are appearing to suit individual tastes. Furthermore, it appears the response time from order to delivery of product is shortening. These trends, in conjunction with intensified competition, place additional burdens on manufacturing operations. If a company is slow to meet the changing needs of the customer, it may be left with unsold inventories or lose the opportunity to sell products ahead of its competitors. Clearly, we need to cut lead time from the consumer order to product delivery by reducing the production lead time. The challenge for us, then, is to reduce setup time and decrease production batch sizes. We also need to reduce inventory levels in our production and transportation systems in order to reduce the risk of carrying unneeded inventories. Think for a minute of a factory producing A and B products. Because of the nuisance associated with setup, this factory may run on the machine 5 A's followed by 5 B's. But if we look at this on the other side, the customer who wants to buy product B has to wait for 5 A's to be completed before he or she can receive the desired product. Because of long lead time, which in turn is tied to long setup, this customer may go to a competitor to buy the product. One solution may be to accumulate a finished goods inventory of B so that you can serve the customer better. But instead of adding inventory and the potential penalties associated with carrying it, why don't we look more carefully at ways to figure out how to reduce setup time? By producing goods in small lots, we can eliminate waste associated with overproduction and excess inventory. The benefits of quick setup and small lot production are many, but the major ones are reduction of production lead time, so the company can respond to customer needs very quickly without much inventory. Reduction of work-in-process inventory, so that problems are more visible. Reduction of defects by early detection, which corresponds to lower inventory levels. And reduction of miscommunication, promoting better communication across the plant.
From what I've heard, it sounds like we need to reduce setup time and reduce the lot size so that we can be flexible enough to meet changing market.
Yes, that's right.
And why haven't we done this yet? Is it because setup time reduction is so difficult?
In the past, we have not put much emphasis on reducing the setup time. Historically, markets were less volatile when compared with today. Also, there was a certain mindset already developed that said we cannot reduce setup time anymore. That mentality stops all progress cold.
Isn't it also true that large lot production is easier than small lot production from an operator's point of view? I mean, if I were to run, stop, change dies, run again, stop, change dies, and so on, well, it sounds like much of a hassle.
Well, if we just think of an operator's work as it is currently done, that is the case. But as we discussed before, the company as a whole will benefit a lot. If we can reduce the setup time and run small lots at all operations, we need to think of total company's point of view.
Does that mean that the assembly line needs to change over more frequently too?
Yes, we call actually such production as mixed production. For example, here's a picture of mixed production. In this case, there are big refrigerators and small refrigerators being assembled, one right after the other.
Oh, that must be confusing for the operators.
Yes, if you're not well organized and don't try to do anything about it, this is the case. But if you can work this out, the benefit will be enormous. In this picture, for example, parts are stored in the rack shown in the middle, and the assembly conveyor is behind this rack. As the model changes in the assembly line, the operator can turn this back around so that the parts for the next model are ready to be used.
I see. Perhaps we need to think about how to reduce the setup or change over time then.
Yes, I believe so.
There are so-called techniques that we can benefit from, whether we are able to reduce the setup time or not. However, we need to emphasize the importance of our challenging spirit in making things happen. Unless we force ourselves to think, our potential capability in these and other critical areas may remain hidden forever. With this in the back of our minds, let us study the basic techniques for reducing setup time. The first step is to separate the work that must be done while the machine is stopped, defined as internal setup, from work that can be done while the machine is in operation, or external setup. Since the setup time should be defined as the time from the last good piece produced to the next good piece, external setup work should not be mixed with internal setup work. A simple time study and videotaping of the setup to separate external from internal work may generate a lot of ideas from a group of operators, engineers, and other support people. The second step is to reduce internal setup by doing more work externally. Preparation of dies, transfer of dies, fixtures, and the like are examples of typical work which can be done externally. Of course, practicing housekeeping and workplace organization are the basic for quick setup. The third step is to reduce internal setup by eliminating adjustments and simplify attachments and detachments. Since many adjustments take as much as 50% of setup, one of the keys to dramatically improving setup is to eliminate adjustments, and not just reduce them. If you believe you can do it, you may just be surprised to find the potential of your own creativity. The same is true for developing simplified attachment and detachment methods. We simply need to question hard and borrow ideas from others. In addition to these, you may also consider adding a person to reduce the internal setup work. The fourth step is to reduce the total time for both internal and external work. We need to practice the basic disciplines of housekeeping and workplace organization, simplify and standardize the setup procedures, and then practice all of these so that people's skills are increased. You may monitor the setup time as you go and share the progress. But the point to understand is there are a number of ways to improve setup times and involve people. By practicing the basic principles, tremendous gains can be made without incurring large expenditures. And the elevated morale will become a major asset both for the organization and for its continuous improvement efforts. Here are a few examples of setup reduction.
In order to reduce the setup time in this department, we had the die racks close to machines, the tools ready next to the machines, the die ready, the machine ready, and also we have the die cars to move the die around. We have a timer so we can start the time. We have a setup log so we can find out we reduce the time on setups. We used to make the setups about 60 minutes, now we do it in 10 minutes. In this machine we have a conveyor so we can move the dies easier to push it inside the machine. And this way the guys take less time to do the setups. Right now he's doing the time of how much time it took to run the parts. Now he's gonna change the die and we find out how much time it will take to do the setup. We have a conveyor back of the machine. We slide the die out. The other one is coming in. Right now, tying the die, the bolts down of the die. Should be ready in about 30 seconds. This took 6 minutes.
This shows a setup operation at a Japanese automobile manufacturer, Kondo Auto Works. As you can see, there are several 1,500-ton presses in this line, producing panels, doors, and other parts for automobiles. Let's monitor the setup time, starting now. Setup is measured from the time the last good piece is produced to the next good piece. Here, an adapter is being exchanged. This is a one-touch operation. Now, the moving bolster is moving into place to exchange the die. As one die moves out, the other one moves in. Very little time is wasted. Because the work has been standardized, there are very few adjustments to be made. The first part moving through the line indicates we are almost at the end of the setup. At the end of the line, the inspector waits to look at the first part. The part appears to meet all specifications. Total setup time, less than 5 minutes. Now, let's see how quick setup is practiced in a high-tech environment.
We basically identified 3 areas that needed enhancement. One was to be able to deliver material components to the station more effectively and quickly, be able to mount the board in the worker holders, quickly to change the worker holder, and also being able to download the program information. This basically has been achieved, and the difference in the before and after situation was change of time before was probably on the order of 1.5 hours down to about 5 to 10 minute range. What is basically involved in order to achieve this all in the way of component delivery, in investing $100 in addition magazine, basically assigning each slot to a particular part number so the magazine could be preloaded with components in the proper slot for a specific product and before it went on the machine. In the way of work order holders, in order to standardize and reduce the set time here, we have standardized the tooling holes, the coordinates of the tooling hole in the board. We have standardized the design of the work of the holding clamps so that change out from one board to another can be achieved very quickly. And also the mean programming the machine and download the program and being able to store in memory programs for different products ahead of time. The cost at the workboard holder level was basically minimal, a few $100. The carousel, maybe $2,000 or $3,000, and program that was merely investment of 2 man-hours.
Here are some more examples, this time from Tokarika, a major automotive supplier in Japan. This picture shows color coding effectively being used to eliminate confusion for the operators. Notice all the good workplace organization here, a place for everything. This is another die storage area. As you can see, die height has been standardized. Good housekeeping is very evident here too. This is a die storage area for aluminum die casting. As this picture shows, each die has the last piece cast placed on top of it. Also, historical records of die machine condition are kept near the point of use in the shop, not filed somewhere in an office away from the action. Here, an operator is changing the die for an aluminum die casting machine. The hoses are color-coded, again reducing any confusion for operators during setup. The die storage area is linked to the machines by railed conveyor, so that dies are easily moved to the machines without requiring a forklift truck. Notice also a color-coded sign attached to each die. The green, yellow, and red dots indicate die condition, allowing operators to easily identify key information. This picture is from the other side. Notice the die storage area and casting machines, with a railed conveyor in between. This shows a machine with die set up and ready to go. Simply by attaching a small conveyor to each machine, die handling is quick and easy. Thus, setup time is greatly reduced.
I understand the basic idea. These examples give me a good lesson about things being well organized. But how does one start reducing the lot size? Can it be that as one reduces setup time, one reduces the lot size as well?
That's right. Then you can also reduce inventory, and production lead time will be shortened. So rather than trying to improve the forecast in this changing business environment, reduction of lead time directly benefits the company. For example, at AMI, they reduced the lead time from 4 weeks or more to less than a week.
So they are now more responsive to market need. At the same time, inventory levels should be lower.
Yes, in their case, it's about, I should say, 70% of previous level.
But if I'm starting all this now, I should focus on the setup time before reducing lot size, shouldn't I?
Well, that's a common approach. Most people want all preparations in place first before attempting to reduce the lot size. But if you were to feel more comfortable, then reducing lot size first may make a lot of sense.
Why is that?
Well, because this way you can expose the key setup operations easily so that you can focus your efforts. This is the same as reducing the inventory level. As you reduce the level of inventory, you know which area to focus on first.
So you are saying that this is continuous improvement. First, expose the problem, then focus resources to solve it. Then further reduce the inventory by reducing lot size, which will in turn expose more problems to solve as you move forward.
Yes, I believe such an approach can be quite effective.
But if lot size reduction is too fast or too big, then what happens?
Well, that means that more programs need to be addressed than you can handle. Thus, the line will stop.
Well, that doesn't sound good.
Well, maybe, but not necessarily, because we can learn from such an experience, and from such learning, the company's resources may be used more wisely. Or perhaps you may learn to slow the rate of lot size reduction so that the situation is more manageable.
Are you saying then that the benefits are big enough to justify this type of experimentation?
Very often, yes. But in order to do this, we need total support management.
And what about the employees? Isn't it important to involve them also?
Most definitely. We want everybody's suggestions for simplifying the setup.
How about investment?
Generally speaking, you do not need a lot of money to reduce the setup time. The key is promoting people's challenging spirit and creativity too. As you succeed, the morale will go up along with improvement.
I understand.
No magic, no fancy systems, just a lot of basics, and run those through consistently, time after time, continually getting better, and driving what we call the avalanche effect. Starting with little projects, successful projects, providing a lot of visibility to those, that creates excitement, which gets another team involved, and then another team, and then another team, hence the avalanche effect term that we use.